Hey, it's Executive Editor Stephen Lacey. Many of you were loyal listeners to a show I created and co-hosted for 8 years called The Energy Gang. Well, we're back. Jigar Shah, Catherine Hamilton, and I are excited to announce our latest project, a weekly news roundtable called Open Circuit. Every week we'll break down how major projects come together, how deals and policies get structured, and what it takes to build critical infrastructure at scale, all through the lens of current events. You can subscribe to Open Circuit wherever you listen to podcasts or follow it at latitudemedia.com.
Latitude Media, podcast at the frontier of climate technology.
I'm Shayle Kann, and this is Catalyst.
I think before we can even scale and before we can even do the regulatory stuff, we need to create the kind of biological tools of this field. And I know it may sound like, how can all these companies exist when I'm talking about this very basic stuff? Well, the world is upside down is all I can say.
Coming up, when and if we might exit the trough of disillusionment for cellular agriculture.
Catalyst is brought to you by Antenna Group, the communications and marketing partner for mission-driven organizations developing and adopting climate solutions. Their team of experts help businesses like yours identify, refine, and amplify your authentic climate story. With over 3 decades of experience as a growth partner to the most consequential brands in the industry, their team is ready to make an impact on day one. Get started today at antennagroup.com.
The electric grid is changing. Utilities need smarter solutions to balance supply and demand, especially as they face growing renewables and electrification. With Energy Hub, utilities can manage all of their customers' connected devices, like batteries, EVs, and smart thermostats, in one platform to grow their virtual power plants and seamlessly shape electricity demand. Unlock the power of flexibility at scale and deliver more value through cross-DER dispatch with Energy Hub, the leading edge DERMS provider. Visit energyhub.com to learn more.
I'm Shayle Kann. I invest in revolutionary climate technologies at Energy Impact Partners. Welcome. Okay, so cultivated meat or cellular agriculture. In principle, I love it. It's a climate solution. It's also great for the avoidance of slaughtering animals. These reasons are obvious. But I don't know that much about it. If I'm honest, that's in part because it really just hasn't scaled to reach me as a consumer. I'm guessing that's true of most of you. So why not? It's been around for a while, so I've been wondering what has held its adoption back. I've had a very loose sense that it's some combination of a regulatory wormhole and incredibly high early costs and maybe some technical challenges in scaling up. I've also had a very loose sense that cellular agriculture is currently somewhere down in the trough of disillusionment on the classic hype cycle. But honestly, any of those things I just said have mostly been guesses. All I've really known is that I'm not seeing it out there yet in the wild, so to speak, as a consumer. But I am curious if that will ever change and what would cause it to change. So occasionally this podcast is my opportunity to finally learn about a thing that I've been meaning to read up on. So let's do it. This is Cultivated Meat or Cellular Agriculture 101. For this one, I spoke to Isha Dattar. She's the executive director of New Harvest, which is a cellular ag research nonprofit. She's also the co-founder of 2 cellular ag companies, Clara Foods and Perfect Day. So she's the right person to talk to about this. Here's Isha. Isha, welcome.
Thanks so much for having me, Shayle.
I'm excited to talk to you about cultivated meat or cellular ag. What is your favorite term for this sector? I assume it's not lab-grown meat.
Well, my favorite term is cellular agriculture because I don't think meat is a sector.
That's interesting.
Yeah.
Cellular agriculture. But is that a broader category? Like, does that apply to non-meat stuff as well?
Yes, for sure.
Yeah.
Absolutely.
Okay. All right. Let's talk about cellular ag then.
Okay.
And I want to start with, I guess, having you walk me through a little bit of the history of this sector. Like, there's been a wave of companies that have arrived. I think they have broadly underperformed expectations, at least from a timing perspective. We don't see cellular ag products all over the supermarket aisles yet. So walk me through the history a little bit and who has been out there, what have they been trying to do, and then what has happened so far?
Sure. I mean, depends how far back you want to go. I mean, we've seen mentions of growing food from cells 100 years ago. Alexis Carrel was a researcher who was trying to grow heart tissue in a jar. And then Winston Churchill had a quote about it in the 1920s. So it goes way, way back. But I think the way back you're talking about is more this kind of recent history, especially with the VC-funded companies.
Mm-hmm.
And I would say that started around 2014, 15. And what happened is we just saw a whole bunch of companies pop up at the same time, all saying, we're going to produce meat from cells. And it's almost 10 years later. Wow. It's 10 years later. These companies, you do see some announcements like little regulatory approvals, tastings here and there. There have been, quote unquote products on the market, but I wouldn't say it's like in a disruptive way. I don't think it's displacing meat really. And that first wave of companies from about 2015, 2016, 2017 all came out saying, we're the beef company, we're the pork company, we're the chicken company, which is a little bit funny because it's kind of mimicking the meat companies that we already know, like this kind of vertically integrated, our business is determined by the animal. But of course, if you're growing meat from cells, you don't have to be stuck to that paradigm anymore. Maybe you're just really great at growing cells, or maybe you're just great at producing media to feed the cells, or maybe you're just great at designing bioreactors. So I think even back then, the disruptive potential was kind of captured in terms of like, oh, this is like the market that we could capture, but it wasn't really realized in terms of this is how the technology actually disrupts how we produce this food. So we saw a second wave of companies that were more this kind of picks and shovels companies was a term that I've heard from a lot of companies out there. And they were the ones that like, oh, no, we just work on the cell culture media, or we just work on growth factors to feed these cells, or we just work on the cells. And I think that helped develop the field a little bit more. A lot of those founders also were a little bit more like coming out of academia. This is a little piece of the puzzle. If we actually think about a world where food is grown from cells, we need a really robust, diverse kind of economy behind it with many different players and so on. We can't just come out of the gate vertically integrated like the meat industry today. It's been interesting because I think that first wave of companies put out some promises that they were going to produce a lot of stuff in a very short period of time. Short in the timeline of biotechnology. And, we haven't seen it yet, but I think in the meanwhile, there is still progress happening. But I think that big conversation that started about 10 years ago, we're in this kind of trough of disillusionment, as they call it in the hype cycle terminology, where people are like, what do you mean this thing will never happen? It's been way too long, when actually it will happen. It's just now we've kind of set ourselves back a little bit and the funding is not flowing as much as it used to.
Yeah, it's a very common, the hype cycle is well known for a reason. But I do want to see if we can isolate like why it hasn't taken off yet. Because I can imagine a bunch of different reasons. I could imagine it's a technical challenge. It's actually just hard to do. I could imagine a scaling challenge. It's easy-ish to do at small scale, hard to do large scale. I could imagine a cost challenge. Like it turns out we can produce this stuff at scale. It's just way too expensive. And I could imagine a regulatory challenge. You mentioned little regulatory announcements, but like it is actually hard, it turns out, to get this stuff licensed. So I'm sure it's some combination, but like how would you rank order the reasons why we've seen a decade of work and put into this, but not yet like widespread adoption?
Yeah, I think there's one, at least one I can think of right now, upstream challenge of all of those challenges, which is a lot of the technology behind growing meat from cells really comes from like the biomedical, pharma, medicine world. And we're talking about food. And food and medicine are still extremely siloed when it comes to funding bodies. Like we have the NIH, the USDA. So that's one example. But also in terms of schools, like a lot of land grant universities are doing the ag research, and it's kind of these like more coastal private schools that are doing the biomedical research. And it's also very separated in terms of just disciplines. Like when you go to do a degree, it's unlikely you're going to do courses in both of those fields at the same time. So when you try to advance an idea like cellular agriculture, even in one lab at one university, it's extremely hard because you don't have the right skills in the right application. You have someone with biomedical fundings like, why would I pursue an ag thing? Like, we have so much funding flowing. We don't need to be as cost sensitive with our research. And then someone in ag may not have as much familiarity with the actual cell culture techniques. So there's kind of that structural problem that's just way upstream of all these other things. If you can solve that problem, which I think New Harvest has contributed a little bit to by, funding research that brings those things together, then you get into the problems that you're talking about, which is actually bringing costs down and scale, regulatory, yada, yada, yada. But I would start with technical challenges as a first challenge, because I think before we can even scale and before we can even do the regulatory stuff, we need to create the kind of biological tools of this field. So as a parallel example, in medicine, we always hear about research with E. coli or canine kidney cells. There's these kind of standardized cells, Chinese hamster ovary cells, that are used all the time to do biomedical research. They're just really well characterized. They perform really well. We don't have those standardized cells in cellular agriculture. So where one researcher in the biomedical space can just open up a catalog and say, hey, I need to order this, this, and this. You understand how they perform and you just get to work on your work. The researchers that we have been supporting have to go to a slaughterhouse, collect cells from an animal, turn them into something workable in the lab. Like it's just a lot of upstream stuff. So we need to do some standards setting before we can even tackle the technical challenges, because we can't ask the technical questions without the research tools. So that's another upstream thing. And I know it may sound like, how can all these companies exist when I'm talking about this very basic stuff? Well, the world is upside down is all I can say.
It's interesting that you describe it that way. I have a couple of technical colleagues on my team at EAP who have pointed out, I think, a similar dynamic in the engineered carbon removal world.
100%.
Which is like basically
Yes.
there has not, in a bunch of other sectors where you have seen this like incredible scaling effect and cost down trajectory, take solar, take batteries, whatever. There were decades of R&D that occurred before this stage we're in right now where stuff is really scaling. And they pointed out to me that that's not true in some other sectors, engineered CDR being an example. And so the risk is, you think you get a bunch of VC-backed companies, you deploy a bunch of capital into them, and you think, okay, like now we just got to solve this little technical challenge and scale. And then costs will come down magically as they have in these other sectors. But if there is not a sufficient foundation of science that has been built up over enough time with enough government funding or whatever it might be, maybe you're getting out over your skis a little bit. It sounds like that's kind of what you're describing here.
Yeah. And I think with climate tech and a lot of just new tech in general, it's like the state of science funding. It's the state of how private a lot of even university research is right now, that we have this upside down kind of inefficient process where it's a lot easier to be a private company raising VC money to do research, which is ultimately should just be basic research, because the stuff that's going to be competitive and on the market probably can't happen until that first research happens. So yeah, I've heard that about a lot of things. And the more I hear about it, the more I think like medicine as we know it is almost like an exception, because it has just like hundreds of years of research and publications and sharing, because the kind of public good of medicine is so well understood. And we don't have that same kind of like public good mentality for these other technologies like climate and food, which I think are just as much mission-driven technologies.
Right. So you've mentioned a few times now, I think the appropriate tie to medicine and biopharma and stuff like that. That also carries with it, I think, what seems to be one of the other core challenges here, which is that in the world of pharma, you can afford to spend a lot of money to produce a little bit of stuff, because the dollar value per kilogram of material that you're producing at the end of the day is going to be extremely high if you're producing drugs. But if you're trying to produce chicken or something like that, it's going to be orders of magnitude less value per kilogram. And so I've heard people describe the cost challenge of cellular agriculture as predominantly one where it is taking tools from another sector with a lot higher value capture, and then trying to apply them here and getting initially the same result, which is you can produce lab grown, you can produce cellular chicken breast or whatever it's going to be, but it's going to be orders of magnitude more expensive than market prices. To a first order, is that like the right way to think about the cost challenge?
I think that is a way to think about the cost challenge, but another way to think about the cost challenge is that biopharma has set this precedent that this is what the price of things should be, and they have no incentive to bring the prices down. Cellular agriculture does have an incentive to bring the price down, and it must bring the price down. And there's a lot of people are attracted to cellular agriculture for all these kind of different mission reasons. Climate reasons, animal welfare. People want to see the end of factory farming. Recently, I've met some people who are into CellAg just because they think that's the only way that biopharma could become accessible to most of the world, is if we bring down the cost in a different place, because biopharma itself will never bring its own cost down. So yes, if we're using biopharma mindset to grow chicken, then yes, it will be very expensive. And it's going to be expensive just out of the gate anyway, because tech is expensive when you start. But I also think if we're willing to have that same disruptive paradigm shifting mentality, that maybe the manufacturer of this looks more like vitamin or food processing or those kind of other still factories, still produce stuff that you consume, but isn't to the level of biopharma, that we really can bring those costs down substantially. And I'll add, like, the price of chicken is not as stable as we think it's going to be, especially in a climate changed world. We're seeing that with the price of eggs right now, with the avian flus. And so, let's not forget that things that seem constant for the past 20 years may not be so constant for the next.
Catalyst is brought to you by Antenna Group, a powerhouse of strategists, storytellers, and industry veterans dedicated to elevating climate leaders. Antenna works tirelessly with enterprises, growth startups, investors, and ecosystem influencers to drive impact across energy, climate, and mobility. With over 3 decades of experience as a growth partner to the most consequential brands in the industry, they understand the trends and moments that matter and how to capitalize on them. Visit antennagroup.com to learn more.
Catalyst is brought to you by Energy Hub. Energy Hub helps utilities build next-generation virtual power plants that unlock reliable flexibility at every level of the grid. The Energy Hub platform takes the guesswork out of balancing energy supply and demand. It uses AI-driven optimizations to precisely shape load profiles and dispatch multiple types of customer devices for maximum grid impact. As the industry leader, Energy Hub helps more than 70 utilities manage 1.5 million devices, more than any other edge terms on the market. Click the link in the show notes to learn more, or go to energyhub.com.
Can we talk a little bit more in detail about the cost? So I think, okay, so we understand if you're trying to do biopharma and then just produce cellular ag, it's going to be a lot more expensive. But walk me through the cost stack. Say I do want to produce cellular meat, whatever kind it's going to be. What are the major components of my cost, and what do we know about where the cost lands today, to the extent that there is data that's relevant here, just to give us some kind of benchmark for how steep is the curve we have to go down?
Okay, so pretend I'm a company and I'm going to manufacture cultivated meat. So what I have to do first is build a facility. Well, actually, even that has some asterisks beside it, because maybe there are existing facilities out there that could be adapted to what I need. I've heard everything from adapting bioethanol plants to using even vaccine manufacturing facilities that are adaptable. So anyway, yeah, we can go down those routes, but you want a facility that can grow cells at scale. So that's a controlled facility. Imagine a brewery kind of visual of lots of stainless steel and so on. Controlled environment, not a lot of staff, just a few. Once you get your process up and running, and it's not like an R&D process anymore, it's just a factory. You don't actually need that many staff. So you build that factory. So that's your kind of first capital cost. The second thing, and the kind of most ongoing cost, is what you actually put into those bioreactors and what you put into the facility. So the media that you're feeding the cells is probably going to be the thing that costs the most. Same like with animals. It's like the feed that's the biggest contributor to the cost of a cow. So media. So of the things in media, there's a lot of basic, water, amino acids, carbohydrates. The things that are really expensive in media are growth factors. And the paradigm of media right now is fetal bovine serum, which is as horrible as it sounds. And that's what is used in biomedical research. And this just ties back to my previous point. This is something that everyone knows we don't need to use fetal bovine serum to grow cells. But we do it anyway because it works. No one asks any questions. Yeah, in medicine, what does it matter? But for food, we have to get past that. And we are past that. Like a lot of people, people have figured that out. We've had serum-free medias for years. So that actually isn't an issue. But that's an example of if we were looking at biopharma, that's one thing where people are like, hey, what about that thing? No, we don't need that thing if we're looking outside of a biopharma context.
So, but like with fetal bovine serum, is the reason we need to get away from that because the whole point is to move away from like an animal-driven industry in cellular ag, or are you saying it's just expensive?
It's both. In my opinion, if we want this mission-driven technology to be mission-driven, we should get away from the animal expenses, and it doesn't make sense for us to still be harvesting cows for fetuses to grow meat without, it doesn't add up for me. But it also is a very big cost center. So that's true. And then the third reason is fetal bovine serum is like an organic thing. Like fetuses are different. If you've ever done research in the lab, you know that you can only do experiments where you use one batch of fetal bovine serum for your experiment because it's so variant from batch to batch. So that's another reason you'd want to get away from that, is if you're trying to do this like big standardized manufacturing process, you don't want to be throwing this like mixture of random stuff in your lot. So those are kind of three reasons. And those are also three valid reasons for pharma too. So if we in cell ag world were able to kind of shift the standard away from FBS, and that was adopted by biopharma, which a lot of people say it is, that would be a win for everyone too. But anyway, I'm a little bit getting off track here.
No. I mean, actually, before we move on to other portions of the cost stack, on CapEx, so we talk about CapEx and feedstock. And the CapEx, I guess I just want an order of magnitude orientation here, right? Is this, if you're going to produce a full commercial scale cell ag factory, is the CapEx, it's not like battery manufacturing, right? It's big stainless steel tanks. It's more like biomanufacturing, right? Or is there something in the CapEx that's quite expensive?
It is biomanufacturing. Well, there's also different schools of thought of if you need like a scale up or a scale out approach. So are you going to have like 1,000 liter bioreactors? Or are you going to have one 10,000 liter bioreactor? And I don't know the answer to that question of which is the better thing to do. Although the people I listen to a lot seem to think that having it's somewhere in the middle. Anyway, but yeah, it's fair. I mean, the cost of steel is also kind of expensive, especially these days. But it's also not that different from other food processing equipment.
Right. So like a full-scale commercial facility, we're talking tens of millions of dollars, hundreds of millions of dollars, billions of dollars. Like what's an order of magnitude?
I would say tens of millions of dollars could make something that's really great. Right now, that would be useful for the whole field. Hundreds of millions, we'd start getting into more like manufacturing in a like way that is more than like a couple Whole Foods carrying a product.
Right. Okay. All right. So that's the CapEx side. And then on the media side, you mentioned growth factors are the big driver of cost, and also where there's this thing we need to probably move away from for other reasons as well. There's other OpEx. I mean, you mentioned not a lot of people, but what are the other big components of OpEx?
Well, so this is a very, very tiny component, so I'm not really answering your question, but we need to, of course, have the cells in there that you're going to be feeding all this stuff to. But if we, live in my ideal world, the cells are some standardized thing that people know how to use, and, they're licensed or something, and it's a very low cost thing. So the cells are part of that. And then I think the other big cost is the downstream processing. So after you actually grow up a bunch of cells and you harvest the cells, what are the multiple steps you're going to take to turn those cells into your final food product? That could be a huge range of things depending on how clever you are in your process, or if you even want to sell a final food product, or if you just want to sell this cell mass as an ingredient or something like that. But I will say, the cell mass is going to be more, quote unquote, processed than like an animal carcass in a sense. Like you won't have to be removing bones and tissue and that kind of stuff, but there will be some other kind of separation techniques. So yes, to summarize, I think the downstream processing is probably the biggest next cost. And then of course there's kind of energy costs associated with the running the place.
Right. Do we have any data points that you think are indicative or valuable at this point as to current production costs?
So there's a great paper written by David Humbert on producing cultivated meat, but I don't want to cite numbers from it because it is very much kind of from within the biopharma paradigm. So it's kind of like if we use the technology that we have today to produce cultivated meat in this context, which of course is kind of higher regulatory standards and stringent and everything, he thinks that cultivated meat is not economically feasible. And I invite people to read that and kind of unpack that more if they'd like to. I'm not going to dig into those numbers because I don't think they're a good apples to apples comparison of where we're actually trying to go with this technology, which is something that is more of like a food processing facility, different scale, and maybe looking at Dave's paper and saying, hey, all these places that are really expensive, that's exactly where science needs to be applied because it has not been in biopharma. It's not saying it's impossible. It's just saying no one has tried to do this because there's been no incentive to do so before. So you can take that. And maybe I'll give you a number and you can choose if it's useful to you. But a couple of years ago, someone put out this little kind of study where they're like, if I bought all laboratory ingredients to make a batch of chocolate chip cookies, how much would the batch of chocolate chip cookies cost? And so you're buying egg powder from Sigma Aldrich and stuff like that. And they costed out all of the ingredients and it cost $30,000 to bake 30 cookies. So $1,000 per cookie. So let that be kind of the, analogy to cultivated meat is like, we're not trying to bake $1,000 cookies. We're trying to bake a regular priced cookie. But we're using the extremely $1,000 ingredients right now.
Okay. So, my takeaway here is like, there aren't great current indicative cost numbers because they probably would be ridiculously high and you don't want to.
Well, or they are low, but they're all happening in the private sector. And so we don't really have access to that information. Circling back to the beginning, where that's what happens when innovation happens in these private companies, is we're not really elevating the whole field all at once. Like they may have made some great strides in the research, but we don't really know about it. And if numbers are out there, they're kind of markety, not always published and unverifiable. And so, that's the other challenge. Is there could be great numbers out there. We just don't have access to them.
If you could wave your magic wand and direct, in fact, this is maybe kind of what you're doing, but if you could wave a big magic wand and direct like lots of research to driving down costs, where would you be directing it? Is it focusing on the growth factors? Is it focusing on the infrastructure, the equipment, the CapEx? Is it something else? Like, where do you think is the biggest lever for cost reduction?
We need to build a few shared resources for the whole field. So I would build a shared facility, which is kind of a first pilot facility, because what's happening now is the companies are all building their own separate facilities. There's no standardization. If one works, great. If one doesn't work, like no one would know why it doesn't work. And then it doesn't prevent the next person from spending their $50 million better on their facility. So I'd create a shared facility, which is kind of more of like an open research place. And it is designed not to manufacture at scale. It's designed to manufacture at some kind of reasonable pilot scale, but designed to be very tunable. So if something goes weird, it's the facility itself can be, and the bioreactors themselves can be tuned. Okay, we need to make it warmer, colder, blah, 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 whatever. And I think that shared facility would really generate a lot of data to help a lot of these companies and inform them how they need to be building their stuff. We also need these facilities because with more open research around a shared facility, we can guide like the regulatory and safety assessments a little bit more in a way that kind of opens things up for everybody rather than having whatever company is talking to the regulator right now set a standard for everybody else. That could actually cut off a lot of innovation before it even starts. So I would do a shared facility. I'd also work on a cell bank for the field, basic cells that everybody can use, really well standardized, characterized, and that too will be synced to kind of a standardization regulatory conversation so that whatever cells we decide are like the basic cells for the field are very likely to be approved, if not already approved, by regulators around the world. So we kind of skip that step for everyone. And those are kind of the two first places I'd start. Media, the only, even though that's a big cost center, that is actually kind of like a good place for business right now because you can sell better media, cheaper media ingredients to pharma today. So from my like open research lens, I don't really think that's a place. I mean, it would be nice, but I don't think that's a place that's going to make as much of a difference tomorrow.
You've mentioned regulators a couple of times. I mean, I should ask, what is the state of regulation around cultivated meat or around cellular agriculture in general?
It's a very active conversation. We have seen several, handfuls of products get approved in different regions, one here, one there. I don't always know if the approvals are like the most significant thing. Like to me, they kind of read like a investor milestone more than this is just like the last stop before we blow our product up on the market kind of thing. And we've seen that actually for a few years. I think the first approval was in 2020, which is like 5 years ago. And we haven't really seen cultivated meat on the market in a way that any of us can go and get it easily. There is an ongoing kind of international safety conversation happening that FAO is cultivating. And, New Harvest has also been running a lot of safety workshops around cultivated meat and seafood, just getting the private sector together and getting governmental scientists on board and just trying to keep the conversation really live. Because the last thing we want is for one company to go to regulators and set a precedent for everybody else, or actually that's the second last thing we want. The last thing we want is a product on the market that is unsafe. And then it just holds back this whole idea forever.
We talked a little bit at the beginning about the first wave of companies, that 2014, 2015 vintage. My sense is that the newer wave of companies, I guess I've noticed two things that seem different. Tell me if this is right, just on the outside. One is, and it speaks to what they're going after. You said the first wave of companies, right? They were like verticalized. I'm the chicken company, the beef company, et cetera. I've noticed more companies, one, doing something other than meat, so focused on cellular ag for dairy and stuff like that. But then second, some of them doing the thing that I would have sort of anticipated, which is like the Tesla playbook, start high-end luxury. So go after, right, like something very expensive so that you can be closer to cost competitive sooner. Is that generally true? Like those are two new frontiers of cellular agriculture startups, I guess?
Yeah. Well, I will say, the 2014-15 vintage companies, I don't know what they're actually doing now. Like they came out of the gate saying we're the chicken pork. What they're actually doing now, I can't comment on. But I think those newer companies that, they come up with a maybe more specific business plan that does tie to that, okay, we actually do need to come up with something that's a little bit higher cost density product. And they also tie it to some scientific reason why it needs to be that way. So one company is called Gourmet, and they're making a foie gras. So, that makes sense. Even if you don't care about being vegan or something, I think a lot of us will be like, yeah, foie gras is a pretty cruel product to eat.
Right,
yeah.
right. It's both expensive and people are, like pretty uncomfortable with how we get it.
So the mission is kind of there, I think, for most people. And then it's expensive. And then it also turns out that liver cells are like a lot easier to grow than muscle cells. So there's a scientific angle there too that's neat to work with. And then also it's just like this mushy pate stuff, which is what cell culture is like. You don't have to come up with this really structured stuff. So that's one company that I think is clever. There's another company we really like called Wild Type that is making salmon sashimi. It's just like, it looks beautiful. It has those kind of striations like salmon does. And I think what's clever about their product is, fish doesn't have the same, fish is a tragedy of the commons. So there is a little bit more of kind of a mission-driven thing there than, ranching or farming, which is like so tied to land and business in a different way than the kind of the commons of the ocean. Salmon, we've talked about salmon and farmed salmon and wild salmon for some time. I think people have some familiarity with that. But lastly, like cultivated products, there's a big scientific process, like food science transformation that happens when you cook something. And cultivated meat, you don't know exactly how it might perform in a pan. You hope it's going to be exactly the same as the cells from an animal, but you don't exactly know. And so what's clever about having the sashimi is you can really control that product when you hand it over to a consumer, and they're not going to go and cook it in some weird way, which I think happens for a lot of plant-based alternatives is, you're not familiar with, you don't cook this stuff the same way you cook meat, or it's not familiar in the kitchen. You can't control the consumer's experience as much. So anyway, the sashimi, I think, is another great example of a clever product that marries the science with a little bit of a higher cost.
All right. So just to wrap up, what do you see happening in this sector in the next 5 years, I guess? Like, paint me an optimistic picture of what it looks like.
Why do I have to paint you an optimistic picture only? No, I do. I am an optimist.
You can paint me a pessimist.
No, I just felt a little bit.
Tell me why it's not going to work.
Led in a direction. No. So I do think we're in a trough of disillusionment. I don't know if we're at the bottom of it or at the just heading into it or where we are in it. But it's an interesting time because it's disillusion from the point of view of a company raising money. But it's not disillusion if you're a researcher. I mean, the research community is actually bigger than ever. There's institutes of cellular agriculture around the world where in 2015 there were 0. There are hundreds of grad students working on cell ag research around the world where in 2015 there was like 2, like I could count them on one hand. So the field is kind of correcting in this trough, I think, because we realize, these companies cannot succeed without basic research. Like regular food and meat science is still a science today. So we're going to have this ongoing science for a long time. It's not like you just check a box and say, oh, this is done, now we can do it. No, this is going to be an ongoing big thing. Cellular agriculture as a concept is so much bigger than meat, and it's very possible that things like milk proteins or egg proteins or just ingredients in our food are actually going to make a bigger difference for the climate and for nutrition and food and a climate change future and food security than meat. Like meat actually might never happen, and meat is just kind of this like holy grail thought experiment that we love talking about, but it may be some totally different other thing. So we do need to expand our horizons to just growing food from cells. And I hope that we see more and more research in that direction because there's kind of more foundational research to stand on the shoulders of in that direction because we already manufacture actually a lot of ingredients that way, like MSG is made by cells, a lot of vitamins are made by cells, a lot of other food additives. And so I think we're going to see a lot more, we call that precision fermentation, kind of, is like producing ingredients from cells, like the milk and egg proteins. I also think in the next 5 years, better science will happen because the distraction of marketing and comms is decreasing. And so all these little kind of news tidbits about what's going on that really, they sound big when they come out, but did they really make a big difference? Like some of these regulatory approvals are going to decrease and you're going to have people that are a little bit more heads down, like thinking about really clever questions that need to be asked. And I actually kind of hope to your point about optimistic, I actually hope the trough gets a little bit worse so that the companies realize they need to work together and they actually just get over their we're competing thing and then say, hey, if we actually pool together the little resources that we have, we might be able to help each other get a thing done, and then we can work on our own competitive things in our own separate directions. So that is my pessimistic, optimistic hope within the next 5 years, is that the companies are actually compelled to collaborate in a way they have never before.
Well, as someone who does eat meat, but cannot bring myself to eat foie gras, I do hope that at least that part succeeds, because I would love to try foie gras. Also true of a bunch of other things as well. But this is really interesting. I appreciate all the time and insight here, and I look forward to seeing what does come out of this sector when it inevitably emerges from the trough, however deep it is. But thanks, Isha. This is great.
Awesome. Thanks so much, Shayle.
Isha Dattar is the executive director of New Harvest. This show is a production of Latitude Media. You can head over to latitudemedia.com for links to today's topics. Latitude is supported by Prelude Ventures. Prelude backs visionaries accelerating climate innovation that will reshape the global economy for the betterment of people and planet. Learn more at preludeventures.com. This episode was produced by Daniel Woldorff. Mixing and theme song by Sean Marquand. Stephen Lacey is our executive editor. I'm Shayle Kann, and this is Catalyst.